feel like every 2 to 3 years, there's a new buzzword that's come around, and everyone has a tendency of focusing on the user interface, the products that are.
Hello and welcome, Sol, to the next episode of the Media House podcast, Simulated Reality. How are you doing today?
I'm doing well. Thank you for inviting me.
Fantastic. So today we are going to talk about the symbiotic relationship between the cloud transformation and the AI revolution, right? But before we deep dive into the topic, right, I wanted to ask why you specifically wanted to speak on this subject, right? What is the significance of these two technologies that you found very relevant to do a podcast? And then maybe we can dive into the topic.
Sure. And it's a great question. So I've been in the data and analytics space since the late 90s, where Excel was and still is the primary data tool used by many corporations and companies. But I've ridden the wave of business intelligence and data engineering and blockchain and IoT and CAMS initiatives and Web 3.0 and big data and ML and data science and now AI. And so I feel like every 2 to 3 years, there's a new buzzword that's come around, and everyone has a tendency of focusing on the user interface, the products that are released out there, but there's very little attention to actually the back-end workloads that fundamentally need investments or are needed to even be able to make those applications work. And so I think sometimes we have a tendency of just glossing over how things are done and made, and we go straight to the pretty product that everyone sees without a true appreciation of all the workloads, compute, GPU, CPU, cloud ops, identity access management, like the non-sexy stuff that no one talks about that seem very defensive driven, but fundamentally power the power of those applications. And so I thought it needed some attention in the space.
Yeah, no, for sure. I think it's the very fundamental nature of cloud as a technology and what AI at the back end demands, right? What do you think are some of the key considerations that need to be made when building an AI application with regards to cloud technologies that can ensure successful implementation of AI and scalability?
I think the area of focus that I'm personally passionate about is applicable to verticals such as oil and gas, mining, industrial, telco, logistics, because what ends up happening is we end up grouping everything as if, okay, cloud operations, cloud ops, well, we need extra capacity to run our LLM models. We'll use an API to ingest the data. And like the words tend to get interchanged. But I think what folks aren't fundamentally aware of is when you actually have an AI application that's gone out of a functioning prototype or has passed the POC and you're wanting to push it into production, it's not code at rest. It is code that fundamentally always needs continuous training as new data continues to get ingested. It's what I call a live wire. It's always living, eating, and breathing. And so the compute costs that go into actually building an AI production ready app is massive. And when you've got industries that are in oil and gas, that are in other verticals like mining and logistics and telco and the ones that I mentioned, the amount of compute that's needed to keep these applications alive is tremendous, and the cost is tremendous. And what ends up happening is when you're pulling in data from sensors, IoT devices, drones, you've not only got the volume of data to deal with, that in and of itself creates challenges. You've got connectivity challenges. So if you're operating in remote areas because you needed additional real estate, or you're running a mining operation, or you've got rigs or power grids out in the middle of remote areas connecting these metropolitan cities together, you've got to worry about things that most companies that are established in main cities don't worry about. So for me right now, I think cloud and compute is a really, really interesting area, because you have these massive companies trying to do big things, and no one is really aware of what it takes from a cloud computing perspective and the cost it's taking. So one of the problems I'm trying to solve with a partner startup, more of a scale-up company of mine, is how do we solve for cloud compute on edge? So if you've got these massive companies that fundamentally rely on sensor, drone, IoT data, how do you process information out on edge, parse out non-essential data from essential data, and then only transmit the essential data through your cloud environment, assuming you have connectivity, so that you could lower the total cost of operation, the TCO, for your cloud ops when running these AI apps in production? And so that's a passion project of mine, amongst others. But I think that's why this is really interesting. People aren't thinking about that. They're not talking about it. And that fundamentally, for me, is a trigger of not many people have AI apps in production yet, because if they did, more people would be talking about cloud compute and how it can be an inhibitor at this point in time, or cost prohibitive.
Yeah. So one of the things that I always wondered, right? What would have happened if we did not have cloud, right? Especially some of the processes that you talked about, right? They sound very technical in terms of the execution and the engineering that goes behind it, right? And these are some of the most state-of-the-art technologies that we're discussing. Imagine if cloud did not happen, what would have been some of the challenges, right?
Well, I think there's a few things. Cloud is a great thing, but I was there during the IBM years where they were pushing their CAMS initiative, and CAMS was CAMS. And it was about mobile security cloud, which was the C. And there was this knee-jerk reaction about, well, I'm not putting my data on the cloud. It's unsecure. It's this, it's that. And there was a lot of pushback and resistance. And now it's the new way of doing business. But if you take a look at the ecosystem, yes, small businesses, cloud, it's just more cost effective. Even medium businesses, companies that are in massive scale up mode, they can idle up, idle down. But if you take a look at the main processing, compute, storage power that's needed for a lot of the Fortune 100 companies that aren't in the most glamorous sectors or fields, that may not be consumer oriented, but are more B2B, a large majority of their footprint is still on-prem. You still fundamentally need the on-prem servers that can support your operations, that have high stability, high reliance, to be able to support the operations. So I think that the world thinks everyone is on cloud, but I think most people are forgetting that IBM mainframes, DB4s, Teradata, they still exist, and they still have a very, very strong consumer base, because some people are still fundamentally reliant on these massive physical data centers. If we didn't have cloud, and I don't think cloud is great for all use cases, by the way, but if we didn't have cloud, I think we would be forced to not only keep the existing data centers alive, but we probably have to create an element of mobility within the data centers. So containerizing data centers so you can drop ship them anywhere these remote locations or verticals operate in, or they have to probably, now that storage and compute is a lot cheaper, reduce the total unit cost of these things so that they could scale. So I'm glad, yes, cloud is around, but I think problems are still solved with on-prem data centers, and we just don't talk about
Yeah.
it. It's not
Yeah,
sexy.
correct. I think most of the conversations that I have had, over the last 2, 3 years, and this conversation especially has, of particular interest to all of the data leaders. What is the right strategy, right? A data or on-prem or data. This thing, I've had very few saying that no, we believe only in on-prem, or some saying we only believe in cloud. It's a good mix of hybrid, right? In that sense, what really plays a crucial role is the entire designing of architecture.
Yeah.
And that forms the fundamental basis of all the projects that will carry on, and its success depends on it. What are some of the key considerations that go behind building a good data architecture, right? Around cloud, on-prem data, as well as embedding it with the engineering systems that enable a successful implementation of AI projects.
That's a heavy question and very big one. But I will give you an example and a simple answer, but it's not my complete and comprehensive answer.
Fair enough.
But when I'm advising or helping companies, I think one of the key questions I poke into is the maturity of the workforce. So for example, I have worked with many companies that want to migrate from, or have migrated from, an on-prem to a cloud environment. I'm like, that's great. If your workloads are light in nature, no problem. But if your workloads are heavy in nature, you absolutely have to do a cost comparison to see if it even makes sense to go and migrate into the cloud. But like, even simple examples that I give is, if you're running a basic analytical function and you've got a non-mature team of business analysts, data analysts, with maybe a few data scientists here and there, who maybe are recently out of school or are PhDs and have always been in a research capacity. They don't have a heavy background in computer science or in data engineering. And so you run the risk that if you do migrate over into a cloud environment, having an inexperienced analytics department where they may run a job overnight, not knowing to turn it off, That's a massive cost to your cloud. Or they may run a query, and instead of doing delta jobs, so let's say they ran their original query for the past 2 years, and they need to run this report on a weekly basis. So what they need to do is pull in the last week's data. But instead, because they're immature, they rerun the entire report for all 2 years. Well, that's a heavy load. If you've got an inexperienced analytics team, or a team that doesn't have the fundamentals in place around computer science, or doesn't have any education in terms of how storage costs are created, compute costs are created, how workloads impact both storage and compute, and they don't know how to optimize their query, don't expect the cost savings, because they're running jobs overnight, queries are running overnight. Sometimes they time out only for them to start over again. They're not pulling in delta loads, they're rerunning an entire query. And most people actually don't even consider this stuff as a element in their framework and deciding which workloads to carry over to cloud and which ones don't. But I've had CIOs come to me and go, our cloud costs have absolutely imploded. We don't know how to cost contain. And I'm like, all right, start with your analytics department. So these are things that aren't even taken into consideration. So part of me is saying that before you decide that you're going to take and migrate from 100% on-prem to 100% cloud, let's take a few areas: manufacturing plants and sensor information, your analytics department and their maturity. Let's just go through and understand the workloads and the necessary GPU, CPU, and storage that's needed to even make sure that it is that there's a cost conscious component of it before you migrate everything over, because it just sounds good and everyone else is doing it. Not to mention, some folks are on-prem environments. Let's say they're using SaaS. If they've got hundreds of models pre-built, and SaaS is a platform that allows you to do the entire data engineering and data modeling lifecycle into a single environment. If all these models are pre-built, no one's taken into consideration all the automated pipelines that have already been built, having to regenerate that into the new environment, and then having to rerun the models in the new environment, and then having to do a control to make sure that they're providing the same output. No one's even considering the migration cost of doing that. And that's assuming you have hundreds. Imagine if you have thousands, because you're a large organization. So for me, going cloud isn't as easy as, yes, because everyone else is doing it, let's doing it. There are so many functions within an organization that even to migrate is cost prohibitive, but because of the immaturity of the organization, will also be cost prohibitive for you.
It's very interesting. I'm going to ask you the question about what are some of the key considerations. The first thing you said is talent. And in a framework where talent forms the most important thing, it becomes like a chicken and egg issue, right? Like where good talent will lead to a good architecture, a good architecture will lead to a good talent. What do you approach first, though? Like, do you ensure your talent is good so that you can adopt to any cloud architecture that you want so that you can do scalable AI? Or do you adopt your architecture based on the availability of talent?
You can design the best data ecosystem and the best data architecture, but if you don't have people who can capitalize or learn or know how to leverage it, it doesn't matter. And so you may not have the business talent to know how to run optimized queries and how to do delta loads, but you need to have tremendous IT talent to put in controls in place that blocks queries from running past 2 hours. But you can't have no talent on either end. So you either have to have a very mature infrastructure and IT team that's already gone through the gotchas and the lessons learned, that they can systematically put the controls in place and teach and train the data and analytics groups that are going to leverage the cloud environment. Or you need a very sophisticated business or a user group that knows query optimization and when things time out and to do delta loads, so that they're not putting such a heavy burden on the cloud environment. So I actually don't think it's a chicken and egg. I always say you can build whatever you want. It doesn't make it successful or popular. So you have to start with either assessing the maturity on the IT infrastructure side to make sure that they know how to put the process controls and places in, and they can actually upskill or train the DNA team, or you need a sophisticated business team that actually knows how to run this function.
Oh, that's a very succinct way to put it, or very, brings a lot of clarity in how the businesses should or enterprises should approach this, right? My next question to you is in regards to the data governance frameworks, right? And this is becoming a very particular issue. AI needs a lot of data. Everybody agrees to that. Cloud is very good at supporting it. But there are some issues or challenges that are coming with regards to the security of the data, or in some cases, it's also about the privacy of the individual data that is being collected, right? What are your thoughts on this, right? What are some of the challenges that you have seen as a professional working at the intersection of these two technologies? And how do you think, especially today when we are trying to implement Gen AI, there will be like humongous amounts of data. What are some of the challenges that we are seeing today in 2023, and how have these challenges evolved over the years?
Yeah. So data governance is a very broad kitchen sink term. And my running joke is you ask 10 people to define data governance, you're probably going to get 100 different answers. So instead of tackling data governance, I'll focus the conversation on like one massive issue that I see that often gets overlooked. And again, no one wants to talk about the non-glamorous stuff and the non-sexy stuff. Everyone wants to talk about the application itself and the business value and all the things it can do. But when we migrated over into a cloud dominant environment, we leveraged things like the data lake in an S3 bucket and just dumping all data, right? We've gotten into this data hoarding mode, which fine, because now storage is cheap, and if you use other native components within any of the big three or big four cloud environments, you can separate for the most part compute and storage is very cheap. My running joke is you can buy a 4 terabyte jump drive for $129 on Amazon now. It cost IBM millions to run 4 terabytes of data in a mainframe in a room, right, in the early thousands. So storage is super cheap. So we end up hoarding a lot of information. More data is better data because everyone always says, I wish I had more access to data. But I think where governance kicks in, and the biggest issues I've seen in the teams that I've led, the companies that I've joined, and the companies that I've helped, we have an amazing ability to just dump data, but we don't have the patience and the tolerance to categorize, catalog, and track the lineage of that data. So what ends up happening is whether you're building an LLM model, or whether you need to provide a data set and a data domain to a data science team that's running a bespoke analysis or prediction model, or whether you need to import that information into your data warehouse environment so your BAs and DAs can run their reports, but now they want to enhance it with new data sets. Fundamentally, the biggest challenge is where can I get access? How can I get access? Or they say everything's in here, but no one knows what's in here. You have this massive S3 bucket. And this is why there's that running joke of the data swamp and the data ocean, because we always end up short circuiting. We always end up taking shortcuts when it comes to cataloging and lineage. So oftentimes you don't know what data domains are in there. And if you do know what data domains are in there, you have absolutely no visibility as to where it came from and if it's the right source of truth. So now the data validity gets questioned. And that's like a big, big no-no if you're in the DNA space. And so if you talk about governance, I say the two steps that we always end up skipping or bypassing or funding never gets approved is the cataloging and the lineage, which gives the validity to the information that you're going to access to begin with. So we end up getting into this data hoarding mode, but we never really organize it, make it available. So we just end up paying for storage. Another way of looking at it is you buy a bunch of clothes and you just throw it all into a closet. You haven't divided it by sneakers and jackets and pants and shirts, so you can't grab and go. What you're doing is sifting through a big pile of stuff that you bought and you just threw it into a closet. How is that usable? And so I think within the overall, what cloud has created is it's reduced the barriers to entry, collecting more data and aggregating more data. But what it's introduced is more concerns around certain governance protocols like cataloging the data and having proper lineage, so you know the validity of where it came from.
And as we come to the end of this conversation, right, one of the things that you said is it's very important to kind of structure or architect this data. So essentially, considering some of the latest developments in AI and cloud technologies, right? One of them could be the utilization of real-time data to kind of churn, go back, store this data, catalog it, as you mentioned, process it, and then reflect it, right? And that is very important as an aspect in Gen AI as well, where the latest queries are kind of taken into consideration to kind of answer the next set of questions. This is just one aspect of it, right? That is influencing the relationship between cloud and AI. If it's similar to this, what do you envision in the coming future? What is the relationship between cloud and AI is going to be like, considering these factors in the next 1 or 2 years, 5 years, and 10 years?
Gosh, I think it's a great question. I don't even know what's going to happen in 2-3 months. So I
Welcome to the world of AI.
answer it. I do. I really do. And I'm not joking with you, but I don't even know what's going to happen in the next 2, 3 months. I mean, just, everyone was building products and building wrappers around, an API, whether it's coming from Anthropic or OpenAI or whatever it may be. And then during Dev Day, it was announced that everyone can now create a GPT. You actually don't need an enterprise license to do XYZ or access to the API. So at this point in time, my goal is just to keep pace week after week without predicting or anticipating what's going to happen in 1 to 2 years. Because Moore's law is in full effect. We are exponentially growing, and like the slowest it's ever going to be is today, which means tomorrow faster and the day after that faster. So even those of us that are in this space, we can't even call ourselves experts because we're barely keeping up with the pace of change. So my honest and humble answer is, I don't know.
That's absolutely fair. Any closing thoughts on this conversation?
I appreciate the opportunity. I think this was a great conversation. And hello to my peers, colleagues, and brethrens who live and breathe this world and are also in the middle of the chaos and trying to figure out what's going to happen.
Fantastic. Thank you so much, Sol, for making the time. I think it brings a lot of perspective into, the complex and the symbiotic relationship between cloud and AI. And it's a very important conversation to have. Thanks again for making the time.